Greetings to all the viewers. The session is going to cover with the natural products called the terpenoids. Terpenoids are the class of natural products where isoprene unit is the essential component in that. We are going to discuss about from which source we can extract the terpenoids, how many types of classifications are available for them, and what kind of biosynthetic pathways are available, and what kind of examples comes under these terpenoid class of molecules. And later on, we will go with the isoprene rule, how they are going to bind up. And finally, applications of the terpenoids. These are the things to be discussed in the session what we are conducting now. Let's enter into our topic called terpenoids. Here, common terpenes and terpenoids. Here are few examples provided which are regarded as terpenes and also called terpenoids. Here see pinene which extracted from the pine tree. So most probably pine, whatever we have a turpentine and pine oil, all these are coming from this pinene only. Then another is about Caryophyllene is another kind of substance. It is related with the pepper. And carine, which is called as cedar. Rosemary, we can say. So rosemary oil is also valuable. So generally, terpenes are called volatile oils, are essential as oils as well. Most of the terpenes and the terpenoids are oily in nature. That's the reason why most of them are having oil type of applications. So rosemary oil, everybody aware that is the kind of oil. So here limonene. So citrus or lemon, there also you can find limonene, that kind of flavoring agent, which is the part of this terpene or terpenoid. Linalool, this is the kind of material extracted from the lavender. So linalool is the terpene extracted from the lavender plantation. And terpenoids like orange peel will be there. In the orange peel, we will experience a kind of fragrance. That fragrance is also the part of this terpene only. Nerol, geraniol, nerol will be there. So lemongrass, from lemongrass, if we squeeze lemongrass, that also giving a kind of fragrance. So that fragrance oil is also the part of this terpene, right? Humulene. Humulene is a kind of a plant from which we are going to extract. Hops plant, we are going to extract this humulene terpene. Geraniol. So from roses, if we are squeezing rose petals, from that also we can experience a kind of fragrance, a kind of perfumery agent, right? That is also a terpene. So wine grapes. From these grapes also we can extract these terpenes. Myrcene. So here, myrcene is the terpene which extracted from the plants which are showing here. These are the kind of few examples which are used to introduce the topic called a terpene, right? So most of the things are daily essentials only. Let's go with introduction regarding these terpenoids. Terpenoids are isoterpenoids are the large class of naturally occurring organic compounds. They are purely made up of what? Carbon, hydrogen only. So basic skeleton is made up of isoprene only. But there are certain different type of arrangement and binding will be there, so that various kind of materials are found for these terpenoids, but basically they are made up of isoprene only. Isoprene is compressed by C5H8 unit, where you can find 5 carbon atoms. These compounds are widely distributed in the nature and are responsible for many plant characteristic flavors, fragrances, and biological activities. Various kind of taste. If you are eating vanilla ice cream, there is a kind of terpene will be there. So here vanillin terpene will be there, and various fragrances like so you can go with limonene, you can go with rosemary. So various kind of fragrances also given by these terpenes only. And so far we can go with pharmaceutical applications. So they are also having medicinal application. For example, let me take menthol. So that mint oil also having the kind of analgesic property. So these many applications, these many kind of applications we can find for these terpenes. So that we are going to discuss about the compounds called terpenoids. Let's go for the classification. How can they can be categorized into various classes? Terpenoids are classified based on the number of isoprene units they contain, right? How many isoprene units are there? So basically isoprene is the skeleton from which all kind of terpenes are made. For alkaloids, the essential component will be nitrogen. For terpenoids, the essential component will be isoprene unit. Okay, based on number of isoprene unit, we can go for the classification over here, right? Monoterpene is nothing but when two isoprene units got combined, so that monoterpene will be found. C5H8 is the fundamental unit for isoprene. When we combine two isoprene C10H16, it will be two isoprene units are the skeleton. The examples under this category will be limonene and menthol, right? So lemon oil we can say, and menthol, mint flavor. So mint plant everybody wear. So lemon and mint both are most common examples. We can daily observe them. Monoterpenes both belongs to. Sesquiterpene is C15H24. 15 composed by how many? 3 isoprene units. If you are combining, that will become C15. So that 3 isoprene units are required for the category sesquiterpenes. Examples under this category will be farnesene and humulene. So these two examples are the part of sesquiterpenes, and let's go with another diterpene. In order to make monoterpene, C10 are required. Diterpene made by C20H32. So that 4 isoprene units, if combined, that is called diterpene, where we can find the phytol and taxol. These are the examples where 4 isoprene units are joined in head to tail or tail to head manner, right? So 4 isoprene units combination is called diterpene. Examples are phytol and taxol. Triterpene is made up of 6 isoprene units. So 6 multiplied with 5 carbons. So that let me go with C30H48. So examples for this triterpene will be squalene and lanosterol. These are the examples for triterpenes. Then tetraterpene. Tetraterpene means where we can find 8 isoprene units. Okay, monoterpene for 2 isoprene, diterpene for 4 isoprene, tetraterpene for 8 isoprene units will be there. 8 isoprenes, 8 can be multiplied with 5 so that we can find C40, right? So here 8 isoprene units are present over. And carotenoids like beta carotene from which vitamin A can be synthesized. So that this is the example under tetraterpene. So this tetraterpene is available in the beta carotene. Let's go with polyterpenoids. Poly means many. Many isoprene units if combined more than 8 we can say, because up to 8 we categorize, right? If beyond this 8 number of isoprene units are going to combine, let's go with another that is bulky, so that polyterpenoid class of molecules we can notice composed of many isoprene units. The example under this category will be natural rubber. Natural rubber is a polymer of isoprene, right? So that you can go with 100, you can go with 1000, you can go with million. These many kind of units may bound. So that polyterpenoids are many isoprene units present in that, where natural rubber is the example, right? By this categorization, our classification got finished. Mono, sesqui, di, tri, tetra, and poly are the classes under this classification. Let's go with properties. How can we assume, how can we observe their properties of terpenoids? Volatility is the essential thing, right? For example, if you are spraying the scent, what happens? Immediately it will disappear because of volatility, right? In the same manner, terpenoid oil also having the nature called volatility. Most of the compounds, most of the isoprene compounds, polyisoprenes are terpenes are volatile in nature, because hydrocarbons are having low boiling point, right? So that immediately they can diffuse and they can convert it into a gaseous form. That's why most of the terpenoids are volatile. Because of this volatile property, they are used as a fragrances. Scent smell will be there, disappearance also there, so that they are these aromas are used as the fragrances or perfumes we can say. Many terpenoids are volatile and contribute to the aroma of the plants. Whatever perfumes we are consuming, which are extracted from the nature, most of them are the class of these terpenoids only, because two properties they are accompanied by. One is about volatility, immediately disappeared. And second is about aroma, that is a fragrance will be there, perfumery tendency will be there. So because of this property, they are used in that kind of sense. Next is about hydrophobicity. Hydrophobicity means if any material which is repelling water is called hydrophobicity. Hydrophilicity means any compound which is easily dissolved, easily mixed up with water is called hydrophilic. Philic means that is associated with. Hydrophobic means it is repelling. So that if we observe carefully, entire terpene is made up of carbon and hydrogen only. Carbon hydrogen is non-polar in nature. So non-polar materials obviously repels the water. If you are adding oil to the water, what happens? Oil is one layer, water is another layer. In the similar manner, whenever terpenes are mixed up with water, water is polar. These compounds are non-polar, so that miscibility is almost negligible. Hydrophobic nature will be observed. That is because of hydrocarbon in nature. All are made up of hydrocarbons which are non-polar in nature. In either structural disciplinary. Here, though we are having isoprene in general, but their combination is in a various dimensions. That's the reason why there is a possibility of existence of alcohols, aldehydes, ketones, and ethers. So many kind of existence of functional groups are available, so that structural disciplinary is also formed. Subsequently, their properties also varied. Optical activity. Most of the terpenes are optically active in nature. If we place in the polarimeter, they are able to rotate the plane polarized light. That's why optically active. And in other segment we entered into called biosynthesis of terpenoids. How can we synthesize within the living organisms? How they are synthesized within the living organisms? The biosynthesis of terpenes occurs through the two major pathways. Two pathways are available. One is denoted as mevalonic acid pathway, found in the cytoplasm of the eukaryotes. Eukaryotes are available here. Any organism which is having the nucleus is called eukaryote. Prokaryote means without absence of the nucleus in that, which is called a prokaryote. Mevalonic acid pathway is available in eukaryotes. Then methyl erythritol phosphate pathway, that is abbreviated like MEP. Methyl erythritol phosphate pathway is also there, which is found in the plastids of the plant. And even in the bacteria also we can observe methyl erythritol phosphate pathway. These two kind of mechanisms are found in order to convert starting materials into the terpenes, right? Both pathways generate the isoprene units in the form of isopentenyl pyrophosphate, IPP. Isopentenyl pyrophosphate will be generated. In addition, dimethyl allyl pyrophosphate is also generated. Later on, they got transformed into isoprene unit, and so many larger terpenoids also manufactured from these kind of materials. This is the way biosynthesis of terpenoids will be carried. One is called mevalonic acid pathway. Second is called methyl erythritol phosphate pathway. Let's go with application. This is called functions of the terpenes, how they are working. Ecological. Ecological means in the ecosystem, in our surroundings, how they are helpful, right? They attract the pollinators and repel the herbivores because of their fragrance smell. Any herbivores which are consuming the plant, they used to generate their defense system so that herbivores can be repelled. Acts as a signaling molecule, so they used to give the signals. So within the organisms, any, for example, if you are experiencing the heat, if you are experiencing any kind of light conditions, we show some activity, some response will be generated. In the same manner, plants are also exhibit a kind of signaling, which is called biosignaling in the plant material, that response, whatever action performed on the plant, whatever response given in the reply to that one, that is called a biosignaling. In that system also, this terpenoids are taking part of medicinal applications. Many terpenoids have the pharmaceutical applications. Obviously, terpenes being these are the natural products, so many kind of plant materials are composed by these terpenoids. They are used in so many kind of therapies, curations, right? So here, artemisinin for the curation of the malaria, Taxol for the chemotherapy in the cancer. So who are suffering with the cancer? In that oncology also, we can go for the treatment with the terpene called Taxol. In the curation of malaria, another terpenoid is applied called artemisinin. This is the way medicinal applications we are mentioned over here. Industrial applications, industries, just now we mentioned volatile and aroma smell are the common features for most of the terpenes, so that these are used in the perfumes and adding flavors. So vanillin is added in vanilla. Vanilla is a flavor, everybody aware about that one. So that is the kind of flavoring agent. Lemon is the kind of another flavor we can say. Lemon flavor is also there. Citrus flavor we can say, orange flavor will be there. All these flavors are given by the compound called a terpene only, right? And even in the manufacturing of biofuels, right? So biofuels are nothing but whatever fuel which extracted from the nature is called a biofuel, right? So just like petrol, diesel, these are the additional fuels we can say, right? So from these sources also it is possible to manufacture the fuels called biofuels, right? Then physiological properties, nothing but precursor for the hormones. Precursor is nothing but starting materials. These terpenes are used to manufacture the hormones. Hormones are very essential in the living organisms, right? Within the body, hormone balance is very essential. If hormone irregularity will be there, that entire living system will be become irregular. So that's the reason why secretion of hormones are most important in the living organisms. Especially terpenes are related with the plant material, so that they are the precursors in the hormone manufacturing, like zebraline. Zebraline is the kind of plant organism which used to regulate the growth of those kind of living organism. And abscisic acid is also there. This is also the kind of hormone in the plant material. So that is also used, that is also synthesized starting from the terpene. And vitamins like vitamin A and vitamin K synthesized from the terpene. Just now we mentioned beta carotenes will be there. That will be the starting material in order to synthesize vitamin A and vitamin K. So this is the kind of applications in a glance which are provided by the compounds called terpenoids. Here is the picture related with that kind of hormones. Hormones maybe of amine hormones will be there, steroidal hormones will be there, peptide hormones will be there. Amine hormones are nothing but composed by the NH2 functional group. Peptides are nothing but protein related hormones will be there. Steroid is nothing but fat related. Cholesterol related hormones will be there. These kind of hormones can be synthesized starting from what? Terpenoids, right? Then vitamin A. Vitamin A is available, whatever things which are mentioned over here, all these are the starting materials, are sources of vitamin A. Very essential for the eyesight, right? This vitamin A is also synthesized starting from beta carotene, that is the terpenoid material. Even vitamin K is synthesized from terpenes only. All green leafy vegetables and even from the fish we can extract the vitamin K. Vitamin K mainly used to regulate the pumping of blood, right? So this is the way applications of terpenes are mentioned. Let's go with the examples where we can found few examples are mentioned over which are related with the terpenoids, right? Monoterpene. So this classification we already gone through. We are going for examples now, right? Limonene, all citrus fruits. So many kind of citrus fruits are available. All these materials are called the class of citrus family. you can find orange, you can find lemon. All these materials, whoever giving that kind of soaring taste, which are of what, limonene family. And next is about the camphor. Camphor is a sublimating material, also having the property of that lightening and the rituals and the spiritual application. We can find the camphor even for medical application. This is used to relieve the pains as well, and even cough tendency can be reduced. So that medicinal applications also the part of this camphor. Right. And next is about sesquiterpene. Sesquiterpene example, artemisinin. Artemisinin, which is having the property of anti-malarial. This is mosquito bite related disease that is called a fever tendency. Malaria fever tendency will be there, which can be effectively curated by means of this sesquiterpene called artemisinin, right? And any other is called a farnesol. Farnesol is mentioned over here. Its composition will be C15H26O. Another oxygen additional heteroatom is also the part of this farnesol. So all these are the part of sesquiterpene. Examples are mentioned with diterpenes. Diterpene means what? 4 isoprene units. If found in that, that is called diterpene. Retinol. Retinol is the vitamin A. Everybody aware, eyesight, effective eyesight can be easily maintained by means of vitamin A. Vitamin A deficiency gives rise to the xerophthalmia and night blindness are the common diseases which occur due to the deficiency of vitamin A. Ginkgo lights. So all another kind of diterpene material. Let me repeat again. Ginkgo lights. So these are also extracted from the terpenes only. So we can see the materials which extracted from the plant. Okay. Next is about triterpenoid, squalene. Squalene is a kind of terpenoid, which is the part of triterpene. And squalene is the starting material in order to synthesize steroids. Steroids, everybody aware about. Steroids are very essential in order to regulate the pain, in order to regulate that fat within the body. Fat can be properly managed by these steroids only, and pain conditions can be managed by these steroids only. Right. So here arzolic acid. Another material is called arzolic acid. Here we can easily observe that arzolic acid. So here polyannular system, polycyclic system it will be. You can find 1, 2, 3, 4, 5 ring systems are available in arzolic acid, right? So here it is also made up of what? A terpene only. So this is also the medicinal material. Let's go with another tetraterpenoids. Examples related with tetraterpenes, lycopene. Lycopene is found in the red color. So lycopene is the kind of pigment we can say, and it is the part of the terpenoid as well. So lycopene, because of lycopene only tomatoes are existing in red in color, right? So and even lycopene, existence of lycopene having the medicinal property that used for the curation of cancer as well. So this is the kind of terpene which found in the materials whichever mentioned over here. So this is the lycopene is the example under tetraterpene. Beta carotenes. Beta carotenes are available in this orange and carrot. This is another juicy material, leafy vegetables, all these. Wherever A vitamin is available, there you can find the beta carotenes as well, because vitamin A synthesized starting from beta carotenes only. So wherever vitamin A is available, there we can find beta carotenes as well. All right. So these are the kind of examples we can notice over here. Let's go with another segment called terpenoids play a critical role in the plant metabolism. So this is the kind of thing what we are discussing is applicability, right? So here, if within the plants, how the plants are able to survive themselves without without any disturbance, that kind of plant metabolism, a kind of circulation of the fluids, a kind of synthesizing their own food materials, a kind of flowering matters, or else ripening technology, or else a kind of growing vegetables from those plants. or else fruits, growing fruits, all these kind of materials, whatever find in that. Even respiration will be there. Plants are able to respirate just like human. Plants are also having the respiration property. So that kind of all these plant metabolism activities got regulated by means of these terpenoids. And even we can find human activities also accompanied by so many kind of applications which are provided by these terpenoids. In the purview of medicinal activity, we can go for antibacterial. So by consuming these terpenoids in a optimal doses, they used to destroy the bacteria related bacteria, whichever disease causing bacteria we can say, they can be easily mitigated. Then anti-parasitic, any parasites are present which are used to destroy these parasites. Anti-inflammatory, wherever pain or else swellings are present, that conditions also controlled by means of these terpenoids. Anti-cancer, they used to cure, because some of the Taxol is the best example where cancer curation is available by means of chemotherapy. Anti-tumor, any tumors, malignant or else benign tumors if present, they also got curated by means of this terpene. Skin protection, they also providing skin protection in with respect to the sunlight and even from the harmful what we can say environments. So UV protection is also valuable by means of these terpenes and the terpenoids. In the another important segment, we can say even in the synthetic organic chemistry, these terpenes have their own impact. They don't stand over there because terpenes are the part of hydrocarbons and the lengthy chains are available. With respect to this terpenes, even from the plants we are able to extract, and some kind of structural upliftment or else structural enhancement we can go with, so that medical properties get enhanced. That kind of research is also carried within the laboratory, so that it is also the part of synthetic organic chemistry. Let's go with another segment called isoprene rule or spatial isoprene rule. How these, so already we are aware, isoprene unit is very fundamental for the construction of these terpenes. How these isoprene units are going to combine in order to make the long chains, because most of the terpenes are polymers only, oligomers, a few are oligomers as well. So if we are going to combine these isoprene units in such a manner, so the lengthy chain will be fabricated. So let's see how the isoprene rule will be followed over there. So this is the kind of a special theory. According to this isoprene rule only, we have to combine all the isoprene units, then only a proper chain will be generated. Let's see. Isoprene. The isoprene rule is formulated by Otto Wallach in the year 1887. Is a fundamental principle in the organic chemistry that explains the structural basis of terpenes and the terpenoids. So here the kind of joining of all the isoprene units first observed by the Otto Wallach in the year 1887. According to this Otto Wallach, these terpenes are able to join in such a manner head to tail, right? So head to tail, in the sense, in order to make the head to tail arrangement, first of all we have to go with the numbering of the carbons. Isoprene is nothing but where you can find 1 2 3 4 5 carbons. It is the 5 carbons branched chain, and first carbon is said to be head. It is mentioned over here. And fourth carbon is mentioned with the tail. So first means that represent the face, head, and last carbon is representing the tail. So this is called head to tail manner. So here head is first carbon, tail is the fourth carbon. Again, the tail should combine with the first carbon of another isoprene unit. This is the way the combination is proceeded, so that how long you want to extend, that extent it is possible to lengthen the chain of this isoprene, polyisoprene units. But the condition will be head to tail manner. Head to tail manner will be there. If we observe the special isoprene rule, there is a possibility of tail to head as well. So that means fourth carbon must be combined with another fourth carbon also. That is another special isoprene rule, we can say. Generally, most of the terpenes or terpenoids are composed by isoprene rule, that is head to tail arrangement will be available. But most of the things, there is another tail to tail arrangement is also possible. Let's see how the combination in accordance with the isoprene rule is possible. First, we are going to consider the compound called myrcene, where here myrcene is a kind of monoterpene, we can say, because so this is 1, 2, 3, 4, 5 is one isoprene unit, 1, 2, 3, 4, 5 any other isoprene unit. These two isoprene units are going to join in the manner fourth carbon of one isoprene, first carbon of another isoprene. This is called a head to tail attachment. And another compound called limonene. Limonene is a kind of annular system. It is a cyclic system where we can go for counting 1, 2, 3, 4. And fifth carbon is there, and another linkage will be there, 1, 2, 3, 4, and fifth carbon will be there. So when they are going to combine in such a manner, so both the carbons are going to attach with another both the carbons of second one, so that we are able to get a cyclic compound. This is a kind of open chain, and limonene is the example for cyclic compound. That is because both the ends of one isoprene can join with another isoprene, so that a annular system will be generated. Again, it is a part of monoterpene only, but it is the annular system. Limonene is the example. Head to tail. Head means the first carbon, tail means the fourth carbon. Retinol. Retinol is the vitamin A. Retinol is also called as vitamin A, where you can find one ring system. Another two branches are available, and extended conjugation you can notice. Conjugation denoted as a double bond, alternative single, double single arrangement is noticed over. This is called the vitamin A. This is the chemical composition of vitamin A, which is very essential for eyesight, right? If we observe first carbon bonded with fourth carbon, first carbon bonded with fourth carbon, first carbon bonded with fourth carbon, this is the way, whatever the kind of system, it will be either open chain or the cyclic one. But the thing is, the attachment of two isoprene units must be in such a manner, head to tail or tail to head. So that is the way we can clearly observe 1, 4, 1, 4, 1, 4. This is called a isoprene rule. Let me go with the lengthy one. Lengthy chain is going to be noticed over here. Whatever this retinol is there, such a retinols two are going to combine over here. Here is one annular system. Here is another annular system. You can notice fourth carbon of one chain is going to join with fourth carbon of another chain. 4-4 linkage that is properly mentioned over here. As of now, all these three compounds are having head to tail arrangement, which is called isoprene rule, where tail to tail, you can clearly notice tail to tail attachment is going to be observed in between two lengthy chains, so that 4-4 linkage is mentioned with this arrow, curved arrow, which is available in beta carotene. Beta carotene is having tail to tail arrangement. Special isoprene rule is followed over here. This is an exception from isoprene, right? And let's go with the application, the part of applications for these terpenes and terpenoids. Let's see. Terpenes have wide range of applications across the various fields due to their disparate biological, chemical, physiological properties. Below are their significant applications. How can we go for the, how can we apply these compounds? Why we are studying about them, right? So pharmaceutical industry. So in the drug or medicinal field, how can we utilize them? So as we already were, artemisinin is the kind of terpene. So whose composition is mentioned over here. Here we have one 7-membered ring, here 6-membered ring, here 6-membered ring. Ether linkage is provided over here. Peroxy linkage is there. Oxygen, if two are directly joining, that is called peroxy linkage. And here another ether linkage is available. And here see double bond. We can't say this is the ether, rather we have to say it is the ester. C double bond O, it is called a cyclic ester, lactone ring it will be, right? So here, triangular fused system it will be, where you can find methyl, and also peroxy linkage, ether linkage, ester linkage. This is the compound called artemisinin, which is effective in the curation of the disease called malaria, right? So which is the what mosquito bite related disease everybody aware about. It is the kind of fever. So this can be effectively curated by this terpene. Another one called Taxol. Taxol is used in the cancer chemotherapy. Chemotherapy means by injecting this kind of terpenoid into the human, we can effectively eradicate the cancer-related symptoms. Cancer tumors can be destroyed. So this is called chemotherapy. By using chemicals, by injecting chemicals, if you are curating the disease called chemotherapy. Fine. Taxol is the kind of compound, very complicated, we can see. We can find so many benzene rings. 3 benzene rings are found over here. And here amide linkage is available. Ester linkage will be there. And either ester, 6-membered, 8-membered, 6-membered, and 4-membered rings also found. Ether linkages are there. Ester linkages are there. Hydroxy are there. So many kind of functional groups are incorporated into the compound, which is effective in the curation of cancer. Another compound is called the ginkgolides. Improve the cognitive function. Cognitive function in the sense, in order to make the sharpening of the brain, in order to make the faster functioning of the brain, that is called a cognitive activity. Immediate response, immediate action, that is available by means of cognitive. So cognitive functioning of the brain, that is given by this ginkgolides, and even blood circulation, which by consuming the kind of terpene, so even circulation of the blood becomes very soft, very effective in the living organisms. These kind of applications we can notice. Menthol. Everybody aware mint or menthol? Menthol is the medicinal plant, we can say, where from this mint menthol terpene will be extracted, right? So this is effective in the curation of pains. So wherever pain conditions are present, there we can apply, or else we can directly consume internally. Internal consumption is also effective for the curation of pains. And cough suppressant, even in the cough, tusky or tussive syrups, we can find this mint flavor over there. That is because there is a property called cough suppressant, cough relieving agent it will be, right? Anti-inflammatory and antimicrobial agent. Anti-inflammatory is nothing but inflammations are nothing but wherever. For example, if we got any kind of injury, there what happens? So pain, in addition, along with the pain, there will be a kind of swelling will be there. So reddish swelling, we can notice that is of muscular damage to the muscles, that causes inflammations. Antimicrobial means so many microbes which causes diseases to the human, right? So all kind of these disease causing microorganisms, that might be bacteria, virus, fungi, algae, whatever the kind of which are minute in nature, these microorganisms which causing diseases can be curated by the compounds called terpenoids. Terpenoids like ursolic acid, carvacrol, effective in reducing inflammations, combating the bacterial infections as well, right? Antioxidant properties. So here we have carvacrol. Carvacrol is effective for what? Where we saw carvacrol. Carvacrol is effective in reducing inflammations. So wherever muscular damage will be there, wherever injury will be there, if you are suffering with the pain with swelling, so that we can go for the administration of carvacrol, so that it will reduce that kind of pain and the swelling. Antioxidant. Carotenoids like beta carotene protect the cell from oxidative damage. Beta carotenes, everybody aware, the long lengthy chain will be there. Here is the ring, here is the ring. Both are going to join in the 4-to-4 linkage. Just now we saw tail to tail arrangement will be there. These beta carotenes are effective in the combating oxidative damage in the cells. Perfumery and cosmetics. Another alternative name for the terpenes and terpenoids are essential oils. Sorry, volatile oils. These are called essential volatile oils. That's why we can apply these terpenes in the perfume industry as well as in the cosmetic industry also, because oily compound, moisture containing compound, sorry, moisture will not be there, volatile compounds. So all these are having that kind of fragrance, that kind of aroma, that kind of what we can say volatile nature. Because of that property, they are used in this perfumes and the cosmetics as well. Fragrances. Monoterpenes like limonene and linalool and geraniol are widely used in the perfumes and deodorants. Deodorants are nothing but which used to avoid the infections and also reduce the sweating smell. So that kind of deodorant will be there. Perfumes will be there, which are made up of limonene, lemon fragrance, lemon oil we are extracting. Linalool also will be there. Lavender, from lavender we can extract linalool. Geraniol will be there. It is also the kind of oil we are extracting and used in the perfumes and deodorants. Essential oils. Essential oils are extracted from plants and terpenoids. Contribute aromatic oils. Lavender oil will be there. Lavender oil. Just now we saw the lavender plantation. From that essential oil will be extracted. Eucalyptus. Eucalyptus plant, everybody know about. Eucalyptus oil also used to relieve the pains, right? Eucalyptus oils we are using for relieving pains, for relieving headache, for relieving nozzle blocks. If we are taking the vapors of eucalyptus oil, so that used to free up our nozzle blocks. And even if headache is there, by consuming the vapors, it is possible to get the relief. Any kind of pain conditions can be mitigated because it is the medicinal plant. Peppermint. Again, it is the part of mint only. Peppermint will be there. So from all these, we are able to extract the essential oils, and they are having the property called oil. The medical properties will be there. Kind of fragrant properties will be there. Perfumery properties will be there. Skincare. Skincare means so many moisturizers we are using from which are extracted from these terpenoids. Squalene is the best example. It is the dry. It is the made up of 3 terpenoid units. Moisturizing and anti-aging agent. Moisturizers, moisturizing creams are available in order to make the skin wet. So in order to avoid the dryness, especially in the winter season, squalene is the material which is incorporated into this skincare product called moisturizing and even anti-aging agent. Food and beverages. Just now we observed that in addition to the fragrance, they are also give the flavor to the food. If you are adding mint to the food, what happens? It will enhance the flavor of that one. In the same manner, here we have cetrol. Cetrol. By adding lemon to the food, what happens? That food taste will be elevated to the next level. Myrcene will be there, and vanillin. Vanillin is the flavor. Vanilla ice cream, everybody aware from vanillin is the flavor. That is the oil we are mixing up in order to make the that material into more delicious, right? So aroma of the food can be enhanced, and that will give the most pleasant taste, right? Natural colorants. So in addition to the flavor or tasty tendency, they're also having coloring agents, coloring material, lycopene. Just now we discussed, lycopene is the red color pigment. Wherever lycopene is there, that material, that fruit, that vegetable existing in red color. Beta carotene, wherever beta carotene is there, that fruit, that vegetable is existing in orange color, or beta carotene some extent orange to yellow shade is available with them. Preservatives. In order to preserve the food material, preserve in the sense we can store them. So in order to store them, we have to avoid the microbes. So antimicrobial property is available for them. So whenever we are mixing any food material can be blended with these terpenoids, they used to fight up with the microbes so that antimicrobial properties available. We can store those food materials for the longer time, especially in case of pickles. These kind of antimicrobial properties are operated over, and they can be preserved for the longer times. Here are some examples: thymol, eugenol, used in the extend the shelf life. Preservation of the food materials for the longer time is valuable for them, so they able to fight with the disease causing organisms, so that they able to increase the lifetime of that food material. So preservatives, we can say. So few drops of this either thymol or eugenol is added to that used to enhance the life of that particular food. We can store comfortably. Even in the agriculture, these terpenoids are working. Biopesticides. Pesticide is nothing but which used to kill the disease causing organism in the croplands. Okay. Here the new term introduced over, perithroids. Perithroids are nothing but that kind of material or disease regulating, disease destroying agent which extracted from the plant materials, perithroids. So it is the pesticide extracted from the plants, which is called perithroid. It is used as an eco-friendly alternative for the synthetic pesticides. Pesticides are available in the market. So in addition to them, we have perithroids extracted from the plants, and which works upon the plants to destroy the microorganisms, which are called biopesticides. Another one is called plant growth regulators. Just now we discussed about gibberellin. It is a diterpenoid. It used to increase the growth of plants. Plant development, it plays a vital role. Here is the gibberellin chemical composition. It is the plant growth regulating agent. Herbicides. Some terpenoids acts as a natural weed suppressants. Okay, so wherever we are growing, especially in the horticulture, or else in the croplands, in the vegetation, wherever we are going, whatever required thing. In addition, so many kind of weeds are also growing. Every time picking or plucking them is very difficult and laborious in nature. In order to avoid all these things, herbicides also very essential. So if we are spraying herbicide, they used to remove all the weeds whichever not required in our field. Okay, so this is the way herbicides also working in agricultural fields. So these kind of plant growth regulators, gibberellin is the part of this terpene only. So that we discussed about, and its a chemical composition is mentioned over here. And we entered into another application, the most important, renewable energy. So here, nowadays, the entire world and even India and everywhere, if you observe, most of the steps are moving towards the renewable energy, right? So energy from the non-conventional sources. So here, even from the terpenoids, biofuels are extracted from the nature, especially limonene and pinene, lime-related, limonene, we can say citrus plants. It is the citrus plant, we can say. And from the pinene also, so here is the pinene, alpha pinene is provided over, where you can find 6-membered ring, even another 4-membered ring is also there. Here is the methyl, here is the methyl gem, methyl are available, and endocyclic double bond is also the part of this one. This pinene is the chemical skeleton which is extracted from the plant called pine trees. So pine trees, alpine forest, from where alpine forest we can extract, even from the mountain region. From where pine trees, coniferous type of plantation, wherever present, there we can extract this pinene. This pinene is also part of this biofuel. Limonene and pinene are rich in this, what we can say, rich in the biofuel potency, right? They are being researched as a sustainable alternative for the fossil fuel due to their high energy density. The potential to convert these materials into the biofuel is extremely large. That's the reason why in the regard of biofuel, these two are having high energy potency, right? So this is another very sustainable mark on the ecological systems. Industrial applications. Rubber industry, polyterpenoids like natural rubber are essential for manufacturing tires and elastic products. So whatever elastic materials we are using, so rubber tires are there, any kind of automobile, if you observe, tires are very essential. And even in the kitchen, we require the gaskets, we require the washers, we require that small rubber things, and even toys, so many everywhere kind of rubber or else plastic materials having their own application. This natural rubber is the essential component of isoprene unit only. That rubber industry plays a crucial role in this terpenoid chemistry, right? So natural rubber is purely made up of what? Isoprene units only. Polyisoprene is the composition. It is the polymer made up of isoprene units, right? So they are having the property of tire manufacturing, and also elastic materials. Rubbers also made up of this kind of natural rubber. Adhesives and resins. Adhesives are nothing but binding agents, glue type of materials. In order to join any two, in order to make constructions, in order to, in the constructions, in the industries, in the household, everywhere we have the application for the adhesives. Adhesives are gum type of materials, glue type of materials. Even resins also having that same nature. Resins, for example, if we are cutting certain plant bark, what happened, they used to secrete some kind of a kind of milk type of material extracting over here, which is the latex. When we are touching that one, it is sticky in nature, that from which only natural rubber will be manufactured. In the same manner, this kind of glue or sticky materials can be transformed into adhesives, binding agents, a glue type of materials. They also blended with the varnishes and even sealants. Sealants are nothing but which used to cover, seal the material, seal the containers. Sealants, we can say. Adhesives. Adhesives just now mentioned, in order to bind up very strict, firmly. Adhesives also essential. So in these fields also we have the application for terpenoids. And another important application for the terpenoid will be the solvent. We can use this terpenes as a solvent. Terpenoids such as turpentine oil. Everybody aware about turpentine oil. Even in the paints and varnishes, we are using this turpentine oil from the pine tree. We are going to extract from the coniferous type of forest. We can extract this turpentine oil, effective solvent in the paints and even in the chemical industry. So just like water is a solvent, right? Water is a solvent for the polar compounds. In the same manner, we can use this turpentine as a solvent in order to mix up the organic compounds, even in the paints and industries as well. This is a kind of industrial application we can go with, and the medical diagnostics, in order to identify the diseases. Diagnosis is nothing but identifying the disease, right? Imaging agent, in order to observe what kind of disease actually there. So imaging agents are very essential there. These are terpenes, being terpenes are pigment or coloring agents. Few of the terpenes are coloring agents, right? They are having the a property called optical imaging. Most of them are optically active in nature, so that they are effective in the optical imaging system in order to identify what disease the people is suffering with. So diagnosing in the diseases, this imaging agent, the terpene will be. Biosensors. Biosensors are nothing but sensors are used to detect the biological and chemical substances. So by using these sensors, what biological system it will be, what chemical substance it will be, that identification is carried by means of these terpenoids. This is about medical diagnostics. Environmental impact. In order to manufacture biodegradable. Now the concern is very high regarding the manufacturing of biodegradable. Biodegradable products. Biodegradable product in the sense, after the usage, if you are throwing into the environment, if it is comfortably mixed up with the soil, that is called a biodegradable in nature, right? So in order to manufacture biodegradable plastic, And even in the cleansing agent, we can blend these terpenes. These terpenes are obviously these are natural products, right? Natural products can blended with nature, so that these terpenes can be blended with the plastic, biodegradable plastics. They are used in the manufacturing of biodegradable plastics, and even in the cleaning agents also can be manufactured. Air freshener. Being these are volatile fragrances, smell containing materials for freshing, in order to make the air very fresh and aroma like and gentle in nature, we can get pleasant fragrances. Various kind of brands are available over here, and air purification sprays also made up of these terpenes. Cultural and traditional. Cultural traditional means neem oil. Everybody aware about neem tree, right? Zadi rakta. So that neem oil, frankincense, neem oil in the sense, if you are extracting oil from this neem tree, that is called a neem oil. From the what we can say, those fruits, neem fruits also present, neem flowers also present, neem leaves also present. We can grind very finely so that neem oil will be extracted. That neem oil is having effective application in the Ayurveda. Traditional Chinese medicine and other practical treat various ailments, various diseases get cured. Even neem oil is having pesticidal activity, and so many disease curation is available with the neem oil. That is the way cultural activity is available. And in either traditional activity, we can say frankincense. Frankincense is nothing but it is the kind of terpenoid. By lightening this material, it used to give the kind of smoke that is having aroma smell, and that is having a kind of fragrance, we can say, which is of the high importance in the traditional rituals. So this is the way we can go for the application in the cultural and the traditional usage. Let's go with another segment called biotechnology and research. In what way biotechnology and research is accompanied by these terpenoids? Wherever DNA got damaged, in order to repair, in order to make the refabrication, these terpenoids are important as a part of metabolic engineering. This is the part of metabolic engineering, right? Synthetic biology. Synthetic biology in the sense, terpenoids serve as a templates for designing new drugs and materials. By applying these kind of terpenoids, a new drugs can be manufactured. That is the way synthetic biology, this segment also accompanied by these terpenoid materials. And another most important application, we say, agriculture as a pesticide, as a nutrient. So this kind of terpenes find their applications. And in the environmental concern, it is most sustainable technical chemical material. By this, we concluded the entire session. Though it is lengthy, but it is more informative and collected with the entire discussion regarding from which source we are able to extract the terpenes and what kind of categories, what kind of classes we can notice over there, and what way these terpenes are generated within the living organisms. And next, we observed what examples are accompanied by these terpene materials. Finally, we gone through the detailed applications of terpenes, the entire session covered by Dr. Kavita Kottireddy Kotam. Hopefully, this is informative. Thank you very much for your patient listening. Thank you, one and all.